We present deferred neural rendering, image synthesis using neural textures. Our approach allows us to resynthesize novel views of an object, edit scenes, and synthesize animations.
I would really say Clinton, probably.
To this end, we propose a unified neural rendering pipeline. Based on video footage of a target object, we estimate its 3D geometry. This geometry is coarse and not suited to be processed by the standard graphics pipeline to achieve photorealistic images. Our approach is able to learn specific components of the rendering pipeline such that we can generate new images based on coarse geometry. Given a 3D model, we parameterize its surface using a UV atlas. Using the standard rasterizer, we draw corresponding UV maps of the object to the image space. This UV map is input to our method. Our pipeline consists of learnable neural textures and a learnable renderer. Instead of classical textures, our neural textures contain learned features that are interpreted by the rendering network. We use the UV maps from the rasterizer to sample from these neural textures. A small U-net is used to translate these features to color values. This pipeline can be trained end-to-end, given ground truth pairs of UV and color maps from the original object video. We first demonstrate the re-rendering capabilities. This allows us to display an object under novel views. Given the UV map on the left, we can generate the output on the right. As can be seen in this close-up, we are able to capture fine-scale details as well as view-dependent effects like specular highlights. Here we show a comparison to the image-to-image translation approach pix-to-pix. As well as ignore an image-guided neural object rendering approach. Additionally, we compare against classical image-based rendering techniques. As can be seen in the close-ups, our approach is able to handle the imperfections in geometry. Since the neural textures are attached to the object's surface, we are able to edit a scene. Given the input sequence and the 3D reconstruction, we can easily duplicate objects in a scene. Using this modified geometry, we rasterize the corresponding UV map, which is then input to our rendering pipeline. Here we show an example of scene editing. Neural textures are a powerful tool which can also enable animation synthesis. To this end, we demonstrate facial reenactment. Given a source and a target actor, we reconstruct the facial geometry and transfer the expressions from the source to the target mesh. The modified UV map, as well as a background image from the target video, is used as input to our rendering approach. Here you can see examples of reenactment sequences powered by neural textures.
I would really say Clinton, probably. I would have to say Clinton.
And why?
There was a little spirit. Frankly, he would have been had he...
President Trump has stated tonight and over again in recent weeks that this country faces a national emergency.
I joined Google 15 years ago and have been privileged to serve as CEO for the past 3 years.
In this comparison, we show the quality of our approach versus state-of-the-art reenactment methods. The rendering quality is dependent on the resolution of the texture. A texture at a single resolution might be too coarse or too fine, which leads to overfitting and undersampling during training. Because of this, we use a hierarchy of textures, resulting in better sampling behavior, particularly for higher texture resolutions. The number of training images influences the re-rendering quality. In particular, view-dependent effects are not well captured with a reduced set of images. Here we show an ablation study of the rendering network. In contrast to a per-pixel network, our U-net-like renderer is able to generate sharper results as well as compensate for errors in the geometry. This ablation study shows the effect of a reduced resolution of the underlying geometry. Even with a coarse mesh, our approach synthesizes photorealistic results. Here we show an extreme case where the geometry is only a bounding box. Nevertheless, our approach is still able to generate an output image. Thank you for watching.